Okay, so in order for us to do integration by completing the square, we have to actually remember how to complete the square. So I gave you this quadratic formula, which is not factorable. Um, you could do the quadratic formula on it, or you could use the process of completing the square. You would have learned it in geometry and done it again in Algebra 2 if COVID hadn't hit. So really quickly, long and short of it is you have to get the x squared and the x term by themselves. So you got to move that 4 to the other side. So we're going to get x squared minus 6x is equal to negative 4. Now what you want to do is you want to figure out something that you can put on the end here so that you have a trinomial that can be factored. The whole point is to be able to factor this thing. And the way that you do that is you copy these two terms down, and then you take half of your b term. So think ax squared plus bx plus c, half of your b term, and you add it squared, which sounds kind of confusing. But the b term here is negative 6. Half of negative 6 is negative 3. So we're going to add negative 3 squared to the left-hand side. There's my lights. However, to keep this equation balanced, if you add negative 3 squared to the left, you have to also add negative 3 squared to the right. Okay, so now what that does is it gives me what's called a perfect square trinomial right here. Now, you don't have to do this next part, but I'm going to show you why this is nice to have. If I were to multiply this out, I get x squared, oh, not plus, minus 6x. Minus 6x, negative 3 squared is 9. This now factors. It's the easy kind of factoring because there's no number in front of the x squared. I'm going to put an x in the front of each. And now I need two numbers that multiply to positive 9, but add to negative 6. So that would be a negative 3 and a negative 3. Because negative 3 times negative 3 is 9, but negative 3 plus negative 3 is negative 6. So this thing factors into a perfect square, right? This is called a perfect square trinomial because it factors into two identical factors. So I can rewrite this left side as x minus 3 squared. Now I don't have to do all of this stuff because all I have to do is notice a pattern. You know, math's all about patterns, right? The x comes from the x squared, and the negative 3 comes from whatever half of b was. So if this was x squared minus plus 8x plus 4 squared, it would factor into x plus 4 quantity squared. Okay, and then on the right-hand side, negative 4 plus 9, because this is equal to 9, negative 4 plus 9 is 5. And then in order to solve this, you're going to simply square root both sides. That's going to give you x minus 3 on the left and plus or minus the square root of 5 on the right. And then I'm going to add 3 to both sides. And typically, we don't see it written like this. Whoops, that was an ugly square root. We don't typically see it with the plus 3 added here because then you get people who write sloppily and they're like, wait a minute, is the 3 under the square root? Is it not under the square root? So what we do is we put it right in the front. So positive 3 plus or minus the square root of 5. And that looks a lot like answers we get from the quadratic formula. So if I had gone back up here and from the get-go done the quadratic formula on this unfactorable quadratic, I would have gotten this answer by using the quadratic formula. But instead of quadratic formula, I use the process of completing the square. So the gist of it is take half of your b term, which is negative 3 in this case, and square it and add it to both sides. That's the whole gist of completing the square. So that's what we're going to be using in the next set of questions when we learn how to integrate by completing the square. Okay? It takes so long to try and get to the stop recording button.